Hello and welcome. In this video, we're going to be taking a look at an integration technique called integration by parts. We're going to learn what is integration by parts and how to use it to solve questions requiring integration. So first of all, to understand what is integration by parts, you need to recall something that's super important from differentiation, which was called the product rule. And I have a video done describing what is the product rule. I'll leave a link to it on the top right hand corner. Feel free to go check it out. So the product rule says if I have two functions, let's say one is f of x, the second is g of x, they're multiplying each other, and I want to get the differentiation of these two functions, then their differentiation is going to equal the first differentiated times the second function. The first function is f of x, second function is g of x. F dash of x means that it's f of x differentiated. And then we add to that the first function normally multiply the second function differentiated. Okay, so let's start from here. Okay, so what I'd like to do from here is I would like to integrate both sides. So basically integrate everything with respect to dx. Okay, because integration by parts, you can think of it as the opposite or the reverse of the product rule. And I will show you what does that mean. So let's take each one and think about the integration. So the first one over here, integration of a differentiation, and we learned that integration and differentiation are opposite processes, and I've done a video on that as well. I leave the link on the right top hand corner. So when you integrate something and differentiate it, you end up back with the same exact thing because they're opposite. They cancel each other. So integration here, you can think of it as a cancel the differentiation here, and you will end up with literally f of x times g of x, and that's it. And then over here you will have integration of f dash of x g of x dx plus integration of f of x g dash of x dx. What I'd like to do is I'd like to take this term over here and I would like to make it the subject. So what I'm gonna do is I'm gonna move this term to the other side and it's gonna become negative. So if I do that, I can do it easily by deleting this. Okay, taking this other side is gonna become minus, and this is gonna equal this term over here. Okay, so all I did is just I moved one term to the other side. Okay, so I have now my equation equals something like this. Okay, so what I will do from here, let me actually rewrite all of it to make this on the left side, so just so it's better. So I'll have integration, I'm writing this term, integration of f of x g dash of x dx is going to equal f of x times g of x minus integration of f dash of x g of x with respect to dx. Now, what I'd like to do is I'd like to do some substitutions. I'd like to literally name my functions different names. What I'd like to do is I'd like to say that my f of x, I'm gonna name it u, and my g of x, I'm gonna name it v. Okay, and I would like to get du by dx is going to be basically the differentiation of f of x. So it's f dash of x. That would give me du as f dash of x multiplying dx. I'm just multiplying this dx to the other side. Okay, and I will do the same for the v. So dv by dx is nothing but differentiation of g of x, which is g dash of x, and dv is going to equal g dash of x times d of x. And right now I would want to rewrite this whole expression or equation that I have in terms of u's and v's. So what I'm gonna do is I'm gonna take each term and I'm gonna substitute with u and v. So for the first term, I have over here, this is f of x, which is basically u. So I'm gonna write this as integration of u, and over here I have g dash of x. What is g dash of x? It's basically dv, right? So u multiply g dash of x, which I can change with dv. This is equal to, okay, f of x is u, g of x is v, so this is nothing but u times v, this part over here, and then minus integration. Okay, let me write g of x first. So what is g of x? G of x is basically v, so it's integration of v. And then what is the integration of f dash of x dx? What is f dash of x dx? F dash of x dx is basically du. So I can substitute f dash of x times dx with du, and I'm going to end up with the equation that we use for the integration by part. So this equation is the one that we're going to use in order to solve from now on the questions for integration by part. Okay, so let's take a scenario or a question in order to illustrate how to use this equation. So the first part of the video, we derived this integration by parts equation. I just didn't want to start by giving it to you and then solving and you don't understand where it came from. Okay, so let's say we have an question that tells me, okay, I want you to integrate x multiply e to the power of x with respect to dx. Okay, what's the integration of this? So from here, I can see that u is multiplying dv. So if I choose something as my u and another thing as my dv, I can rewrite into this equation right here. So what I'm gonna do is I'm gonna choose u to be x, okay, and I'm gonna choose dv to be ex to the dx, to ex dx, okay? So this part over here is u, this part over here is dv. Let me start by getting du by dx, which is basically differentiation of u. So it's gonna be 1, okay? And from now on, I'm just gonna multiply dx to the other side. So I'm just gonna write it straight away. Du equals 1 multiplying dx. Because this dx was over here, I just moved it, multiplied it to the other side, okay? And what about v? If I want to get v, I basically integrate dv by dx. So v is the integration of this thing. And I know the integration of e to the power of x with respect to dx is basically nothing but e to the power of x. So this is the first step you should do in order to solve equations involving integration by parts. You need to choose what is your u, what is dv, okay? Then get your du by differentiating u. Get your v by integrating dv, and then you have everything set up. As we go, I'm gonna give you hints, okay, and ways to know which one to substitute as u and which one to substitute as dv. Okay, so let's continue from here. So this thing is going to equal what? uv, so my u is x, my v is e to the power of x, so it's basically x e to the power of x, minus integration of v du. V is e to the power of x, du is basically 1 dx, or basically dx. So from here, I can rewrite this as x e to the power of x minus integration of e to the power of x is basically e to the power of x. And then I have c, and this is going to be the answer to this problem over here. This is the integration of this problem over here. Okay, so mainly how to choose your u and your dv. Whenever you're choosing something as u, in the back of your mind, you should know that this u, you're going to differentiate it. So you'd want something that differentiates easily. So x, I know I can differentiate it as 1 very quickly, okay? The same thing goes for dv. dv, you're gonna choose something that you're gonna integrate it to get your v. So you don't want something super complicated to integrate, okay? So let's take another example. Let's say we have a question telling us to integrate x cosine x dx, okay? And let me always copy this over here just to rewrite it as, okay, let me rewrite it. So I know that integration of u dv equals uv minus integration of v du. So from here, again, the first step, I'm going to choose my u and my v. I'm going to choose my u as x. Okay, that makes my du as 1 times dx. And I'm going to choose my dv as cosine x dx. And that makes my v the integration of cosine x. And I know that the integration of cosine x is sine of x. Now let's use the formula in order to solve. Let me choose to copy this. Okay, so from here we can say that this is going to equal to uv, so it's x sine x minus integration of v du. So my v is sine x, my du is 1 times dx. So from here I can say that x sine x minus, what is the integration of sine? The integration of sine is basically negative cosine of x, and then I will have the constant of integration. So this is equal to x sine x, negative multiply negative is going to become positive cosine of x plus c, and this is going to be my answer. Let's take a look at another example where we have integration of square root of x multiply ln of x dx. Again, I'm going to paste this over here. Okay, let's choose our u and our x. So first of all, I know that the integration of 1 over x is ln x plus c. That makes the differentiation of ln of x basically 1 over x. Okay, the integration of ln over x, of ln x, I don't know, and it's a complicated process. So over here, since I know the differentiation of ln x is simply 1 over x, it's smart to choose my u as ln of x. So I will choose my u as ln of x, and that directly gives me my du going to equal 1 over x dx. And that leaves my dv with root x dx. Or I can write root x as x power 1 over 2. This makes my v the integration of x power half, which is going to be add 1 to the power. So 1 half plus 1 is 3 over 2. Divide the new power. Dividing 3 over 2 is the same as multiplying 2 over 3. So this is my v over here. Now let's use this equation. So I will have uv, which is going to be ln x times 2 over 3 x power 3 over 2. So I'm going to type in the 2 over 3 x power 3 over 2 first, and then multiply ln x. This, I'm going to subtract from it the integration of v du. So v is 2 over 3 x power 3 over 2, multiplying du, which is 1 over x dx. And from here, I can continue. This first part is going to be unchanged. Minus, okay, I have an x power 3 over 2 on the top and an x power 1 on the bottom. This is basically 3 over 2 minus 1, which is going to be half. So I can replace this with x power half. So this is going to be 2 over 3 x power half dx. Let's now integrate this over here. So this part is unchanged. Minus, okay. Integration, I'm going to add 1 to the power. So 1 plus half is basically 3 over 2. So I'm going to have an x power 3 over 2. And then I'm going to divide by 3 over 2, which is the same as multiplying 2 over 3. And then I'll not forget my constant of integration. So I can rewrite this as 2 over 3 x power 3 over 2 ln of x minus, actually plus, because minus 2 over 3 times 2 times, oh no, this is, sorry. This is just multiply. It's not negative. This is multiply. It's not negative. So minus 2 over 3 times 2 over 3 is minus 4 over 9 x power 3 over 2 plus c. And that is my answer. let's paste this over here. And let's take another example. Let's say we have an example telling me integrate x e power negative x dx. Over here, let's choose our u and our dv values. So our u is going to be x, because differentiating x is going to simply be a 1, and that will make my life so much easier. And that leaves dv as e power negative x dx, which is this part, because you split it into 2 parts. V is going to be the integration of that. So integration of e to the power of negative x is basically e to the power of negative x divide or over the differentiation of what's inside, which is going to be differentiation of negative x, which is -1. So it's basically negative e power negative x. You can think of this as an integration by use substitution problem, where I did a video on that, and I will leave a link on the top right hand corner. So integration of e to the power of negative x, I can choose my u to be negative x, then my du is going to equal -1 times dx. So this is going to equal integration of e power u du, which is basically du is, yeah, so dx, I can change this dx with negative du. So there will be a negative over here, which is going to give me an, after integration, negative e to the power of u plus c, which is negative e to the power of negative x plus c. Okay? So let's erase all this. Okay, so now I got my u, my dv, du, dv, everything is set. Let's start using our equation. So this is going to equal uv, which is x times negative e power negative x, minus integration of v du, which is negative e to the power of negative x, times du, which is basically dx. Okay, so over here I'll have negative x e to the power of negative x, negative times negative is positive, integration of e to the power of negative x dx. This is equal to negative x e to the power of negative x, and then the integration of this again is going to be negative e to the power of negative x plus c, and this is going to be my answer over here. Let's take a little bit of a harder question. Let's say we need to integrate x squared cosine 3x dx. Okay, again, this is a type of question where we will need to use integration by parts 2 times, and I will show you why. First, let's choose our u as x squared. That makes our du as 2x dx. Our dv, let's choose it as cosine 3x. That makes our v basically the integration of cosine 3x, which is going to be sine 3x over the differentiation of what's inside. Differentiation of 3x is 3, so it's over 3. Okay? Let's now use our equation in order to solve. So our equation is basically uv, so x squared times v, which is sine 3x over 3, minus the integration of v du. V is sine 3x over 3. Du is basically 2x dx. So multiply 2x dx. So I can rewrite this as x squared sine 3x over 3 minus 2 times 1 over 3 is basically 2 over 3. I'm going to take it outside of the integral, and I'm going to have inside as sine 3x multiplying x, or I can just put the x in front over here with respect to dx. Again, this integration over here I will need to use the integration by parts one more time in order to integrate this expression. So I'm gonna have my u as x, which is this part, and my dv, I'm gonna have it as sine 3x. So dv is sine 3x. That makes my du as 1 dx, and my v as integration of sine 3x is basically negative cosine 3x over the differentiation of what's inside. What's inside is 3x, differentiation of that is 3, so over 3. Let's rewrite this again using the integration by parts rule. First I have this part, then minus 2 over 3 into the integration of this. I'm gonna use the integration by parts formula once again. So it's uv, so it's x times negative cosine 3x over 3. So I'm gonna put in negative x cosine 3x over 3 minus the integration of v du. So negative cosine 3x over 3 du is basically 1 times dx. And then I have a constant of integration outside. Over here, I can simplify. So this is going to be x squared sine 3x over 3. Let's multiply this inside and distribute it over here. So it's going to be minus 2 over 3 times negative 1 over 3 is basically plus 2 over 9 x cosine 3x. And then I have a minus here times a minus here. So this becomes a plus times negative 2 over 3 is minus 2 over 3. And then I have an over 3 over here. So this is going to be over 9. Integration of cosine 3x dx. Okay, so basically, and I have a plus c. So basically, the only thing that's left is to just evaluate this integral, and this is super easy. This is going to be, let me rewrite everything. So I have a 1 over 3 x squared sine 3x plus 2 over 9 x cosine 3x minus 2 over 9. Integration of cosine 3x is going to be sine 3x over the differentiation of what's inside, so over 3. So 9 times 3 is basically 27. So I can change this with 2 over 27. And then I'll have a plus c over here. And this is going to be my answer for this question. Okay, let's take another question. Let's say we have integration of x squared e to the power of 5x dx. Okay? Again, if you want for a reminder, the formula for integration by parts, we need to choose a u, we need to choose a v. U here, try and guess what I'm gonna choose, and if you guess correctly, then good job. X squared, and then du is going to be 2x dx. I'm gonna have my dv as e to the power of 5x dx. That makes my v the integration of this. So integration of e to the power of 5x is basically e to the power of 5x over the differentiation of what's over here. So differentiation of that is 5. That gives me my v. Let's start using the equation. So it's going to be uv, which is x squared e to the power of 5x over 5 minus integration of v du. So 2x times e to the power of 5x over 5 is going to be 2 over 5x e to the power of 5x, or I can basically take this 2 over 5 outside of the integral to leave me with this, and I have a dx over here. Again, this part over here, I will need to use integration by parts one more time to evaluate it. So let's do that. Let's say that we choose u as x. That makes du as 1 dx. Let's choose dv as e to the power of 5x. That makes v equal to e to the power of 5x over 5 again. Let's do the integration by parts for the second integral. minus 2 over 5 into uv, which is x e to the power of 5x over 5, minus the integration of v du, which is e to the power of 5x over 5, times du, which is basically 1 dx over here. I have a plus c. This is plus c as well. Okay, so over here I can write it as x squared e to the power of 5x over 5. I can distribute this negative 2 over 5 is going to become negative 2 over 5 times 1 over 5 is negative 2 over 25 x e to the power of 5x, minus negative 2 over 5 times minus 1 is going to be plus 2 over 5 into the integration of this part over here is going to be basically, so this part over here I can integrate it as e to the power of 5x over 5 dividing the differentiation of what's inside, so dividing 5. Okay, so it's equal to e to the power of 5x over 25. So e to the power of 5x over 25 plus c. So multiplying these two together is going to give me 5 times 25 is 75. So it's going to be this whole thing divided 75. So I can rewrite this as 2e to the power of 5x over 75 plus c. And this is the correct answer. Yes. Okay. Let's take one more example. Let's say we have integration of ln of x plus 3 dx. Okay, so let's paste this over here. Okay, so integration of ln, I don't know. I know the differentiation of ln is basically 1 over x. Differentiation of ln of x is 1 over x. So over here, it's smart to use my u as ln of x plus 3. That makes my du as 1 over x plus 3, multiply the differentiation of what's inside. Differentiation of x plus 3 is basically 1. So multiplying 1, or I don't even need to write it. This is times dx. Right, what is my dv? This is the same as ln of x plus 3 times 1, right? So I can choose my dv as 1 dx. And this simply makes my v as integration of 1 is basically x. So now let's use our equation to try and solve. So this is going to be uv, which is basically ln x plus 3 times x. So I'm going to write it as x times ln x plus 3 minus integration of v du. So x multiply 1 over x plus 3 dx. Okay, so this part over here, how can I integrate it? I can do so by using u substitution, and I've done a video on u substitution that I'm gonna give you. It's link over in the top right hand corner. You can watch it and understand how to do u substitution. So let's take this and try to integrate it. Okay, so this I can write it as integration of x over x plus 3 dx. Let me do my u substitution. Let me choose u as x plus 3. That makes my du as 1 dx, which is the differentiation of x plus 3. Okay, and over here I can rewrite this as integration of x over, instead of x plus 3 I'm going to put in u, instead of dx, and I'm going to put in du from here. But I have a problem that I have this x over here that is solved by solving for x in this part over here. So x is going to equal u minus 3. So I can replace this x with u minus 3. Okay, so the integration of this, I can rewrite this as integration of u over u minus 3 over u with respect to du. So integration of u over u is 1 minus 3 over u. respect to du. Now I can integrate it normally. Integration of 1 with respect to du is basically u. Integration of minus 3 over u is minus 3 ln of u. Now I can replace my u with the original substitution, which was x plus 3. So this is going to give me u, which is x plus 3 minus 3 ln of x plus 3. And this is going to be my integration for this part. So let's rewrite it over there. So it's x plus 3. So let's rewrite this part, x ln x plus 3 minus the integration of this we found as x plus 3. Let's do a bracket minus 3 ln of x plus 3 plus c. Over here I can distribute this minus, so it's going to be x ln of x plus 3 minus x, and then it's going to be minus 3. Okay, and this minus 3 is basically a number that could be added to this c to give just one constant of integration. So I'm going to add it to the c and I'm going to remove it from here. So minus x plus this times this is basically 3 ln x plus 3, and then plus c, and this is going to be my answer for this question over here. Let's take a final example, okay, which is a little bit tough. Okay, let's say we want to find the integration of cosine 2x times e to the power of negative x dx. This is also a question where we will need to use the integration by parts rule more than once. We're going to use it 2 times. So let's start by choosing our u as cosine of 2x. That makes my du as negative sine 2x multiplying the differentiation of what's inside. So differentiation of 2x is basically 2, and then I have a dx. My dv I'm going to choose as e to the power of negative x dx. So that makes my v equal to integration of that is going to be e to the power of negative x, divide the differentiation of this, so divide negative 1, which is basically negative. So now let's use our rule. There's going to be uv, so negative e to the power of negative x times cosine 2x, just multiplying these two together, minus the integration of v du, so negative e to the power of negative x multiply du, which is negative, I'm going to put this 2 in front, 2 sine 2x dx. So let's simplify a little bit all these negatives. So this is going to equal negative e to the power of negative x cosine 2x. This minus I'm going to distribute it inside the integral. However, I have a minus here and a minus here, so this becomes plus, and this is a minus, so this is minus integration of, I'm going to put this 2 in front, or actually I'm going to put it outside of the integral, it's the same thing, sine 2x dx. Again, I will find this integral. I need to evaluate it by using integration by parts again. So let's do a new u and dv substitution. So I'm going to choose my u as sine 2x. That makes my du equal to cosine 2x multiplying the differentiation of what's inside, so multiplying 2 dx. I'm going to choose my dv as e to the power of negative x. Again, the integration of that would give me v, which is going to be negative e to the power of negative x. Okay, so let's rewrite this integral again using the integration by parts formula. So we will have, this is going to be the same, minus 2 times uv, which is negative e to the power of negative x times sine 2x, minus integration of v du, which is negative e to the power of negative x, multiply du, which is 2 cosine 2x dx over here. So let's try and simplify this part. So this part is going to be the same e to the power of negative x cosine 2x minus, let's distribute this minus 2 inside. So minus 2 times minus e to the power of negative x is going to be net plus 2 e to the power of negative x sine 2x. And then this over here, a minus and a minus is going to be plus, plus. Negative 2 times that is going to be minus 2 times the integration of e to the power of negative x. However, I have another 2 over here, so I'm going to multiply it to that 2. So this is going to be 4 e to the power of negative x cosine 2x dx plus c. So again, I will find that this part is very similar to the first integration that I started with. Integration of cosine 2x e power negative x, integration of cosine 2x times e to the power of negative x. So what I can do here is, I know that this whole thing is equal to the integration of this part. So this whole thing is equal to the integration of cosine 2x, because this is my original equation. So what I can do is I can move this to the other side of the equation, so it becomes plus 4 integration of this thing, and I can add these two terms together because they're exactly the same. This is dx. Okay, so let's try and do that. Let's rewrite this part, e power negative x cosine 2x plus 2e power negative x sine 2x plus c equal to, I will have an integration of cosine 2x e to the power of negative x dx, and then plus 4 integration of e to the power of negative x cosine 2x dx. I can see that this term is exactly similar to this term. So this is basically a 1, this is a 4. I can combine them together. 1 plus 4 is 5, so I can erase all this and put this as 5 integral of cosine 2x e to the power of negative x dx. So if I want to find the answer for this, I can basically divide by 5 both sides. So this is going to give me, this 5 is going to cancel with this 5. So this over here is going to be the answer to the integral, which is integral of cosine 2x times e to the power of negative x. And this is a very difficult question for integration by part, where you need to notice this thing. However, usually when we have a trig function multiplying an exponential function, usually we end up with something like this. So by practice, you will notice these things and you will find it easier to solve. Anyways, thank you so much for watching. Please don't forget to like, comment, subscribe, and please, if you have any questions, feel free to leave them down below. I hope this video was helpful, and thank you for watching.